This is a homework problem. This is question number 3 out of 5.1. And the directions say use the summation properties and formulas to rewrite and evaluate the sum. So the first thing I'm going to do here, I'm looking at the sum starting from k equals 1 to 25. If it's 3k squared, that's really the same thing as 9k squared minus 5 times the sum of k going from 1 to 25 of k. Okay. I'm going to go ahead and bring out that 9 in front. So I'm looking at the sum of k equals 1 to 25 of k squared minus 5 times the sum of k going from 1 to 25 of k. Okay, so the first thing I need to figure out is, do I have a formula for the sum of consecutive squares? And the answer is we do. Here's the formula for the sum of consecutive squares, okay? And y'all, I'm going to go ahead and bring in another picture too and see if I can find it. Here we go. And we also have a formula for the sum of consecutive integers, right? Right here, the same one we used the other day. All right, so for the sum of squares, it's going to be n times n plus 1, 2n plus 1 over 6. And that's where my last number, my top number there. So look, we're going to have 9, and then I'm going to come back here. Instead of an n, we have a 25, and have 25 plus 1 more, a 26. And then we have 2 times 25, which would be 50 plus 1, 51, okay, all over 6, minus 5 times, let's see, the sum for consecutive integers. Again, remember, n is 25. So that's 25, that's 26, and that's a 2. So 25, 26, and all over 2 right here. So what am I going to do? I'm going to use my calculator to do this part, right? 9 times 25 times 26 times 51 divided by 6. Okay, let's clear this out. 9 times 25 times 26 times 51, all divided by 6. 49,725. Minus 5 times 25 times 26 divided by 5. 650. And then I'm just going to subtract. 49,725 minus 650 is 49,070. And I'm done, right? Okay. And there was a secondary problem, so I'm not going to actually solve the whole thing, y'all. I'm just going to set it up for you. Okay. Excuse me. This is problem number 4. Let me see if I can load this up a little bit better. Here we go. All right. So again, I'm going to do the same process. I'm going to look at this first part. So I'm going to take that negative 4 on the outside. I'm going from k equals 1 to 30 of k squared. Okay. Plus, I'm going to take that 7 out. So let me write that 7 out here in the front. And I'm going from k equals 1 to 30 of my number k. And then a minus k equals 1 to 30 of my number 3. Okay. So look, we've already done this first part right here. We've already done something like that here. Now this is the part we got to figure out. So I'm going to come to my notes, y'all. And let's see, here we go. I'm going to take a little screenshot. I want you to look at that first one. If you're adding up a sum from 1 to n of a constant, it's just n times that constant. Okay. So let's upload that picture right here. Let's crop it. The only piece we're interested in right now, y'all, is that piece right there. Okay. So if I'm adding up a sum from 1 to n of a constant, it's n times whatever that constant is. So this is going to be negative 30 times that constant. Okay. And then again, you can just fill in the blanks using the formulas that we have here. Okay. Anyway, if you got questions, let me know.